So wind is flowing 100 kilometer per hour. Here we have to say the direction also. Hello? ഞാൻ സ്റ്റുഡിയോയിലേക്ക് വന്നേക്കുവാണ്. ഞാൻ വൈകിട്ട് എത്തുള്ളൂ. ഇനിയിപ്പോ അങ്ങോട്ട് ഇനി വരത്തില്ല ഞാൻ. So we have to say if the wind is flowing from north to east, or we have to say north to south. Yes, we have to say like that. Direction is a must. So when we are saying both magnitude as well as direction, we can call it as a vector quantity. Vector quantity. So that is the difference between a scalar and vector quantity. So wind, the velocity of car. Velocity of car means it may be 35 kilometer per hour flowing, moving from some direction to other direction. So here also we have to say about the direction. So if a quantity have both magnitude and direction, both magnitude and direction, we can call it as a vector quantity. If a physical quantity only magnitude, no direction, we can call it as scalar quantity. Then what are the types of vectors? Types of vectors. For example, one is null vector. Null vector, or we can say that zero vector. For example, I am standing here at the point A. After some time also I am here only. So my net movement, I can say that it is A, from A to A only. So what is the magnitude of this AA? It is actually 0. Therefore this vector is known as null vector. For normally a vector, there will be 2 points. This is starting point. For example, this is A. We can call it as initial point. Initial point. The other one is terminal or ending point. Terminal point. So we are starting from A and we are reaching B. So this is represented as vector AB, where A is the initial position and B is the terminal position or terminal point. So in zero vector, our initial position or initial point and final point both are same. Then we can say that this is a zero vector because magnitude is 0. For example, another case, if we are moving from A, then finally we are reaching B. After we are moving to C, then we are coming back to A. So A to B, B to C, then C to A. So my initial position and final position both are at A. So the resultant, I can say that this is A to A only. So here also A to A matlab, that is the meaning means the same point. So here also magnitude you are getting 0. So this is called as equal vector. Another one, sorry, that is null vector or zero vector. Another one, equal vector. Equal vector means here you can see one vector A, one vector A, another vector B. If I am checking the magnitude means length of this segment, we can call it as the magnitude of the vector. So magnitude is represented like this. Magnitude of A is represented like this. Similarly, magnitude of B is represented like this. When we check, if I am, if I check the magnitude of A and B, I got a result that magnitude of A is equal to magnitude of B. Then I observed the direction. Both are on the same direction. Both are on the same direction. This is actually both are parallel vectors. If vectors are on the same direction, we can call it as parallel vector. If vectors are opposite direction, one is going like this, one is going just opposite to that, we can call it as anti-parallel vector. So in parallel or anti-parallel vectors, if a vector is, if two vectors, their magnitude and direction both are same, then we can call it as A is equal to B. Vector A is equal to vector B, because the magnitude of A equal to magnitude of B, at the same time direction is also same. Therefore, the name equal vectors. Another one, unlike vector. Like vector, like and unlike vector. Like vector and unlike vector. For example, like vector, here we are not checking the magnitude, whether they are on the same direction. We can call it as like vector. If a vector is going like this in some direction and another vector is going in some other direction, direction is different. We can call it as unlike vectors. Like vectors are parallel also. Like vectors, both are having the same direction. Magnitude may be different, but the direction is same. We can call it as like vector. If that is not the case, that vectors belongs to the category of unlike vector. Then what is negative vector? Negative vector. Negative vector. Negative vector means you have a vector like this, A, another vector like this, B. You observe that magnitude of A is equal to magnitude of B, but direction is opposite. This is a type of anti-parallel vector. And that is a special case of anti-parallel vector. So magnitude is equal, but direction is opposite. Then you can call it as B vector is the negative of A vector. Or you can say A vector is the negative of B vector. This is the condition for negative of a vector. Here A and B, both magnitude is equal, but direction just opposite. So one vector can be called as the negative of the other vector. Then another type, co-initial vector. Co-initial. What is co-initial? Co-initial vector means here you have a vector starting from A to B. I will call it as AB. Another vector starting from the same point but going to a different direction. So this is A and this is B. Since both vectors have the same initial point, we can call it as co-initial vector. Similarly, co-terminal vector. Co-terminal vector. What is co-terminal vector? Here, a vector is starting from A to B. Another vector is starting from C to B. When we are observing both these vectors, AB and CB, you have two vectors, AB and CB. The ending point is same for both the cases. So we will call it as terminal point same. So we can say that Both are coterminal vectors. Then what is collinear vector? Collinear vector means, for example, this is a vector A, another vector on the same direction or opposite direction. Same direction or the opposite direction. But the second vector is above the other. For example, I am going to draw a vector like this. This is the second vector B. Both are on the same points. We can say that A and B are collinear vectors. A and B are collinear vectors. Opposite case is also same. So for example, this is A vector, another vector is in the opposite direction, but on the above the same vector. The second vector above the first vector. Then you can say that collinear vectors. One important condition of collinear vector is, if you have a vector A and another vector B, both are collinear, means this is B vector and the first one is A vector. If they are collinear, it may be with the same direction or it may be with the opposite direction. Then you can represent one vector as a scalar product of the another vector. So A and B can be related like this. So here lambda, the value of lambda is greater than 0. Then you can say that A and B are on the same direction. If lambda is greater than 0. If you want to relate two vectors A and B such that A equal to lambda B, and where lambda is a scalar quantity, if lambda is greater than 0, then you can say that A and B are on the same direction. Collinear, but at the same direction. Another one, lambda is less than 0, then A and B will be opposite in direction. So that is the condition of collinearity of two vectors. Then addition and subtraction of two vectors. Addition and subtraction of two vectors. Addition and subtraction of two vectors. Here we have to discuss about two types. One is triangle law of addition. Triangle law of addition. Second one, parallelogram law of addition. Parallelogram law of addition of two vectors. When we have to apply triangle law of addition or parallelogram law of addition, that is depending on the vectors. At what time both are applied. If we want to consider triangle law of addition, the vector, one vector is applied after the other vector. If we want to use parallelogram law of addition, then both vectors should be applied simultaneously. Both vectors should be applied simultaneously. For example, if here somebody is playing a football, one football is here, a person kicked that and the ball is coming to this particular point. This is from A to B. Another guy is kicking the same football from this position and this ball is moving like this and reaching this point. That is C. So first vector AB, the force is applied along AB. Second case, the vector is applied or the force is applied along BC. So here force is applied one after the other. So what is our initial point? Initial point is A and final point is C. So the resultant vector can be represented as AC. AC is represented as the resulting vector. So here AC can be represented as AB plus AC. AB plus AC. Let go. Here you can see we are starting from A. Then temporarily we stopped at B. From where you stopped, that from that point itself you have to start again. Then B to C. So here you can say A is the initial point, C is the final terminal point. So what is the resulting vector? AC. So AC can be written as AB plus BC equal to AC. If AB is considered as vector A and B is considered as vector B, then AC can be represented like this, A plus B. So here this AC can be, if it is A and this is B vector, then AC can be represented as A plus B. A plus B. So this is the case of triangle law of addition. Another case, parallelogram law of addition. Here a ball is here. A person is kicking that football from this position. Another guy is doing from this position. He is attacking like this and he is attacking like this. So here two forces are applied on the same point simultaneously. Here you have to apply parallelogram law of addition. For example, here is the first force is like this. The force applied by the first person and the force applied by the second person is like this. So we are applying force simultaneously. So here you can see we can complete this diagram with a parallelogram. In triangle law of addition, the third side represents the sum of the other two vectors. In parallelogram law of addition, the diagonal will be representing the sum of two vectors. For example, here A, here B, the resultant can be represented as the diagonal. So A plus B, the resultant will be A plus B. In concept wise, both are same. Triangle law of addition and parallelogram law of addition, both are same. The result will be same. In triangle, the third side will be the sum of the two vectors. In parallelogram law of addition, the diagonal will be the sum of the two vectors. Then another one important concept is free vector. This can be considered as a classification, free vector and localized vector. Free vector and localized vector. What is free vector? If you are allowed to take a vector to any point in space without changing its magnitude and direction, this vector can be taken to this point, but we should not change the magnitude and we should not change the direction. So if a vector is allowed to take to any point in space without changing the magnitude and direction, then such vectors we can call it as free vectors. Localized vector means a vector is like this from A to B. If the initial point is fixed, if you are fixing some stick with a nail, that stick cannot be removed from that point. Similarly, if the initial point of a vector is fixed at a fixed point, then you are not allowed to take that vector to any position. That vector should we have to keep there only. Such a vector we can call it as localized vector. In mathematics, when we are dealing with the vectors, in this portion we are completely dealing with the free vectors only. We are not at all discussing about the localized vector. All vectors are considered to be as free vectors. So coming back to the parallelogram law of addition, here you can see this vector B, if we are considering it as a free vector, that vector without changing the magnitude, you can change that vector into a different position. So that B can be put here also. Here we are not changing the length of that vector or the magnitude of the vector, and we are not changing the direction also. Therefore, because we are considering all vectors are free vectors, so without changing the magnitude and direction, you can take that vector into anywhere in the space. So I have shifted B from this point to this point. Now this look like a triangle. So A and B are the two sides of a triangle, so the third side will be A plus B. In parallelogram case, this is B and this is A. Both are adjacent sides of a parallelogram. They are the adjacent sides of a parallelogram. So the resultant will be the diagonal of that particular two adjacent sides. So diagonal will be representing the sum. In both cases, sum will be common, but in triangle of addition, we are saying that is third side will be representing the resultant. In parallelogram, the diagonal will be representing the resultant. In triangle law, we have to use when we have to use if the forces are applied one after the other. In parallelogram law of addition, we have to consider if the both forces are applied simultaneously. Similarly, subtraction. What is subtraction? Here you can see one vector A, another vector B. B, another, if B is taken into reverse direction, we are not changing the magnitude. We are simply changing the direction of the B vector. So if the direction is changed, that can be considered as negative of B. Now also you can see one triangle is formed, A, B, C. Here AB is one of the side, BC is the other side. So if we are moving from A to B first, then B to C, then resultant will be from A to C. Resultant will be from A to C. So this can be AAC can be represented as AB plus BC. What is AB? A. BC, what is B? BC means minus B. That is equal to AC. So here you can represent A minus B. This is the only idea about subtraction of two vectors. Subtraction of two vectors. Matlab, when you are adding two vectors A and B, that is addition. If you are adding a vector with a negative of some other vector, for example, B is an actual vector. If you are considering the negative of B, then A is added with the negative of B means actually both vectors are subtracted. So that is about the subtraction of vectors. Then we can have some idea about the uh, addition of two vectors. For example, here you can see a vector A. Vector A. This is vector B. Then resultant is represented like this. This is actually A plus B. So if A is extended like this, so the angle between A and B can be represented like this, theta. Angle between two vectors can be represented like this. So what is A plus B the whole square? In vector, normal multiplication is not there. Instead of that, we are using two types of multiplication. One is dot product, another one is cross product. Dot product and cross product. So A plus B the whole square means A plus B into A plus B. So when you are multiplying A plus B into A plus B, we have to consider the concept of dot product. A dot A, then plus A dot B plus. So A dot A dot B, then B dot A, B dot B. B dot A plus B dot B. A dot A can be written as modulus of A square. A dot B is A dot B and B dot A. A dot B plus B dot A plus mod B square. A dot B can be A dot B and B dot A both are same. Therefore, mod A square plus 2A dot B plus B square. So this is the expansion of A plus B the whole square. A plus B the whole square matlab A plus B into A plus B. But we have to consider two types of product. In normal algebra, we are multiplying 2 into 3 means 2 into 3, 6 we are writing. But in vector, such a type of multiplication is not there. We have to follow dot product and cross product. These are the two types of multiplication in vector algebra. Dot product matlab, the meaning is dot product is actually a scalar product. If we are taking the dot product of two vectors, we will get a scalar quantity. If we are multiplying two vectors, if we are taking the cross product of two vectors, we will get a vector quantity. Dot product is normally represented as vector A dot B. Is the answer will be a scalar. Cross product is represented as A cross B. Answer will be a vector. So cross product is also known as vector product because the final answer is a vector quantity. A dot product is also known as scalar product because the final answer is a scalar quantity. Before going to this rule further, first I will discuss about some idea about the position vector of a vector, then what is magnitude, that things I will discuss. One important concept you should know about the vector is in normal Cartesian coordinate system matlab x, y, z. X, y, z. If we want to represent the point in that Cartesian coordinate system, we will represent like this: x, y, z. That is a point P. The origin is here O. The coordinate is 0, 0, 0, 0. 0, 0, 0. The position vector means the position of that vector in this space is known as position vector. That is represented as x comma y comma z. That can be represented as xi. That is vector OP is represented as xi plus yj plus zk. Xi plus yj plus zk. So x is the position of that vector. That is the how much distance, if that distance along x direction, along y direction, along z direction represented by x, y, z. So position vector is represented based on the corresponding coordinate xi, yj, zk. So magnitude. What is magnitude? Magnitude means the length of OP. Length of OP. So in normal two-dimensional algebra, distance formula, you know, if there are 2 points x1, y1, z1, x2, y2, z2, then distance between 2 points can be represented as d equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. The same thing we can apply here. Here x2, y2, z2 can be considered as x, y, z, and x1, y1, z1 can be considered as 0, 0, 0. So distance is equal to, so here the magnitude of the vector OP equal to root of x minus 0 the whole square, y minus 0 the whole square, z minus 0 the whole square. So you will be getting OP equal to x square plus y square plus z square under root. That is the length of the vector OP. For example, if you are given with a point, for example, in a three-dimensional coordinate system, y, x, z, a point is given as 2, 3, 4. The point is P. This is origin O. So this is OP. Then OP, the length of OP, the vector OP can be represented as 2i plus 3j plus 4k. 2i plus 3j plus 4k. What is the length? By distance formula, 0, 0, 0. So 2 minus 0 the whole square, x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So here, since x1, y1, z1 is 0, you can represent like this only. 2 minus 0 the whole square, 3 minus 0 the whole square, plus 4 minus 0 the whole square. So we will be getting 2 square 4, 3 square 9, and 4 square 16. So 16 plus 4, 20, 20 plus 9, we will get root of 29. That is the length of the point OP, or the magnitude of the vector OP. So this point is with respect to origin. So we can call it as the position vector of OP is 2i plus 3j plus 4k, and the magnitude of OP is root of 2 square plus 3 square plus 4 square, that is root 29. Another example, if a point is given as 4, 2, 0, x can be 0 or anything. So OP can be represented as the magnitude of OP. So OP can be represented as 4i plus 2j plus 0k. 4i plus 2j plus 0k. So magnitude, what is magnitude? 4 square plus 2 square plus 0 square. So 4 square 16, 2 square 4. So you will be getting 16 for plus 4 20. So that is the length of the magnet vector OP, and the position vector OP is 4i plus 2j plus 10k. So here one point is considered as origin and the other point is a particular coordinate. Here for example, A, B. A is given as 2, 3, 4. B is given as 5, 6, 8. So this 2, 3, 4. 2, 3, 4 indicates the position vector of A. 5, 6, 8 indicates the position vector of B. So what is vector AB? So here we are starting from A and reaching up to B. So my initial point is A and the final point is B. So my vector can be represented as AB. So what is the length of AB? Again, you can use this distance formula for that. For calculating the uh, vector AB, you have to consider final point position vector minus initial point position vector. AB means here AB is the starting point and B is the final point. So position vector of the final point minus position vector of the initial point. OB minus OA. What is OB? You can minus, do minus for the corresponding x coefficient can be subtracted from the x coefficient, x coordinate, and 6 y is the y coordinate can be subtracted from the y coordinate. So 5 minus 2, 3i, 6 minus 3, 3j, 8 minus 4, 4k. So this is the vector AB. So position vector of OB, B minus position vector of A. So magnitude will be, you can consider AB magnitude is equal to root of 3 square plus 3 square plus 4 square. That is 9 plus 9 plus 16. 9, 16 plus 9, 25 plus 9, 34, root 34. That is the length of AB and the vector is 3i plus 3j plus 4k. Then here you, while representing the position vector, for example, the point A, 2, 3, 4. Position vector can be represented like this. 2i plus 3j plus 4k. So what is this I, J, K? What is this? I. We are providing I with a cap. Normally vector is represented with a bar above. With arrow, without arrow, both are same. But I is represented with a cap. J is represented with a cap. K is represented with a cap. If a vector is shown with a cap, we can call it as unit vector. That is another classification of vectors. Unit vector. If the magnitude of the vector is equal to 1, if the magnitude of the vector is unit t, then we can call it as it is a unit vector. So I, J, K are unit vectors along 3 different directions. That is y-axis, here x-axis, either z-axis. A vector along the direction of x. A vector along the direction of x-axis with a magnitude 1 is represented as I cap. If a vector along y with a magnitude 1 is represented as j, the vector along z direction with a magnitude 1 is represented as k. So I, j, k represents the unit vectors along 3 different direction, means along x, y, z axis. The unit vector along x axis towards the x axis direction, that is known as I. The unit vector along the positive direction of y-axis, that is known as j. The unit vector along positive direction of z, that is represented as k. So that is ijk. Suppose another one question regarding the unit vector. For example, you are given with a vector a, 2i plus 3j plus 4k. So for example, this is the vector. So what is the magnitude? Magnitude can be represented as 2 square plus 3 square plus 4 square, that is equal to 4 plus 9 plus 16 equal to root 29. So the length of this vector is equal to root 29. We know that 25, root of 25 is 5, and root of square of 5 is 25, and square of 6 is 36. So 29, so root of 25 will be 5 and root of 36 will be 6. So root 29 will be in between 5 and 6. So for example, this is value is near about 5.38. Root 29 will be 5.38. You need to represent a vector along the same direction of A. You need to represent a vector along the same direction of A, but its magnitude should be equal to 1. If you are able to represent a vector along the direction of A with magnitude 1, then we can call it as that is a unit vector along A. For example, if it is root 29, its length is 5.38, but I required only a unit vector with a magnitude equal to 1. So what I have to do, the original vector is divided by root 29. If the original vector is divided by its magnitude, the resultant vector will be of unity magnitude. For example, the A is the actual vector and A cap is the unit vector. If A is this vector and its length is root 29, then unit vector can be represented like this. This is A cap. Magnitude is equal to 1. Magnitude of A cap is equal to 1. And magnitude of A is equal to root 29. So if this root 29 is divided by root 29, you will get 1. You will get 1. That means if a vector is divided by its magnitude, you will get another vector along the same direction. You will get a vector. If a vector is divided by its magnitude, you will get a unit vector along the same direction. So this is the important formula. A cap equal to vector A cap equal to vector A divided by magnitude of A. But we should not think that unit vector is always small. It can be smaller than the original vector or it can be bigger than the original vector. I will tell you the example. If a vector is with length 36, in order to get a unit vector, you have to divide that vector so that you will get a unit vector with unity magnitude. Another example, a vector with length 0.5. The length is actually 0.5. So unit vector means the length should be 1. So here the vector itself is small. So in order to get the unit vector along the same direction, I have to get the double of this one. So 0.5 plus 0.5. Then only I will get total 1. So you can say that If the vector magnitude is less than unity, unit vector will be bigger in size. If the magnitude of the vector is less than unity, the unit vector will be bigger. If the vector magnitude is greater than 1, then the unit vector will be smaller. That is the best example is this. If 36 is the magnitude, then we have to get a small vector with unity 1. If the magnitude is 0.5, in order to get a magnitude of 1, we have to double that vector. Not always double, based on the condition. For example, it is 0.25. In order to get the unit vector, we have to get 4 times. Then only 4 into 0.25, you will be getting 1. So, if the magnitude of a vector is less than 1, unit vector will be bigger than the original vector. If the magnitude of the vector is greater than 1, the unit vector will be smaller than the original. That is the concept of unit vector. That is, unit vector A cap is equal to the actual vector divided by the actual vector magnitude. So here the vector A and the unit vector A, both the direction is same. Both are the same, both are in the same direction with the different magnitude. That is the concept of unit vector. So I, J, K are the unit vectors along X, Y, Z direction. So if I is a unit vector, what is the magnitude of I? 1. If J is a unit vector, what is the magnitude of I? 1. If K is a unit vector, what is the magnitude of K? 1. So I, J, K, these are the vectors with the unity magnitude along the direction X, Y, Z respectively. That is the idea about I, J, K. Then there are two products, dot product and cross product. These are the basic multiplication of two vectors. One is dot product and the other is cross product. Dot product, the resultant will be scalar, hence the name scalar product also. Cross product resultant will be vector, hence the name vector product also. So dot product is also known as scalar product and cross product is also known as vector product. So dot product between two vectors A, B can be represented as A dot B equal to mod A mod B cos theta. Mod A mod B cos theta. So what is theta? Theta is the angle between the two vectors. Angle between two vectors. Then we can check the different cases. For example, so first of all, A dot B is equal to mod A mod B cos theta. So if the two vectors are on the same direction, so angle between two vectors is theta equal to 0 degree. So A dot B equal to mod A into mod B cos 0. Cos 0 is actually 1. So A dot B will be coming as mod A mod B. If theta equal to 90 degree, the vector will be like this. This is A vector and the other vector is B. So angle between the two vectors is 90 degree. Therefore, E dot B equal to mod A mod B cos 90 degree, cos 90 0, therefore 0. Then another case, theta equal to 180 degree. Here one vector is like this. The other vector will be opposite direction. This is A and this is B. So angle between the two vector is theta equal to 180 degree. So in this case, A dot B become mod A mod B cos 180. Cos 180 is minus 1. So A dot B can be represented as minus A vector A into minus A into minus A vector modulus of A or magnitude of A into magnitude of B. So these are the cases. So angle can be theta can be 0 degree or angle can be 90 degree, angle can be 180 degree. But here you can observe, if theta is 90 degree, the dot product becomes 0. If theta is 90 degree, the dot product becomes 0. So in this case, this is y, this is x, this is z. The unit vector along I is I cap, the unit vector along y is j cap, and unit vector along z is k cap. So what is the angle between two axes? X and y will be 90 degree and y and z will be 90 degree. Similarly, x and z is also 90 degree. Means the angle between, because I, j, k are the three unit vectors and they are mutually perpendicular also. I is acting on x direction, positive x direction, j is acting on positive y direction, k is acting on positive z direction. So the angle between I, j, k, they are mutually perpendicular. So angle between any of the two pairs will be always theta equal to 90 degree. So what is dot product of I dot j? I dot j equal to mod I mod j cos 90. Cos 90 is 0. Therefore, I dot j is 0. So I dot j is 0. J dot k is 0. K dot I is 0. There is no difference between I dot j and j dot I. Both are same. Just to see the equation. I dot j equal to I in mod I into mod magnitude of I into magnitude of j into cos 90. J dot I is also equal to magnitude of j into magnitude of I into cos 90. There is no, if I magnitude of I and magnitude of j is just, that is equal to magnitude of j into magnitude of I. So I into j, magnitude of I into magnitude of j is equal to magnitude of j into magnitude of I. So there is no difference. Therefore, I dot j and both j dot I both are meaning is same. But I and j, the angle between I and j is 90 degree. Therefore, the dot product will be always 0. What would always 0? Because theta is 90 degree. But I dot I dot I dot I means both are unit vectors with 0 degree. Theta is 0 equal to 0 degree. So I dot I can be represented as magnitude of I into magnitude of I into cos 0. Cos 0 is 1. So magnitude of I is 1. Magnitude of I is 1. So 1 into 1, 1. So I dot I is 1. J dot j is 1. K dot k is 1. So I dot I, j dot j, k dot k, all are 1. So important relation you can see. I dot I equal to 1, J dot J equal to 1, K dot K equal to 1. I dot J equal to 0 or J dot I also equal to 0. Both are equal. Then J dot K equal to K dot J equal to 0. Similarly, K dot I equal to I dot K equal to 0. These are the important results regarding unit vectors I, J, K. Dot product is 0 when the angle is 90 degree. Then cross product. Cross product is cross product. Cross product, when you are calculating the cross product of two vectors, um, you will get a third vector. You will get a third vector. So when you are doing cross product of two vectors, cross product of two vectors, you are getting a third vector. So the result is also a vector. So we can call it as this product is vector product. Another name is vector product. Then, for example, here one vector A, another vector B. So dot product is represented as A dot B, but cross product is represented as A cross B. A cross B. So A cross B, matlab you are calculating like this. A cross B. So when you are doing A cross B, A cross B, A cross B, A cross B, you are doing like this. When you are turning a screw like this, it will be going towards the that side. If it is A and this is B, you are going A cross B, matlab A cross B, matlab you are turning like this. So you are removing the screw. So screw will be going towards you. If you are doing like this, screw is coming, going opposite to you. If you are doing like this, screw will be coming towards you. So A cross B, if you are considering A cross B, then the third vector that can be represented as C, for example, C equal to A cross B, then it will be perpendicular to both the vectors. A cross B, matlab you are doing like this, A cross B. So you are turning the screw, you are tightening the screw. So screw will be going inside. So A cross B, so this will be C equal to A cross B. Here order is very important. Not like A dot B. A dot B is equal to B dot A. A dot B equal to B dot A. But we cannot say that A cross B is equal to B cross A. This is a wrong statement. A cross B cannot be equal to B cross A. But A dot B equal to B dot A. This is a valid thing. A dot B equal to B dot A, but A cross B cannot be equal to B cross A. देखो, this is B, this is A. Now you are doing like this, A cross B. Matlab, you are moving like this, moving like this. So like this, like this. So you are removing the screw. So your screw will be coming towards your side. So in this case, this is C. And this C is both perpendicular to A and as well as B. Angle between C and A will be 90 degree. At the same time, angle between C and B also 90 degree. This is also 90 degree. This is also 90 degree. That means If you are calculating the cross product of two vectors, the third vector will be perpendicular to the both vectors. So you have to consider a direction in such a way that the third vector will be perpendicular to the both the vectors. That is cross product. So A cross B, this will be A cross B. B cross A means you have to do like this. B cross A. B cross A means you are tightening the screw, so screw will be going. So this can be written as D equal to B cross A. So direction is opposite. A cross B is always opposed to B cross A. So you cannot say that A cross B equal to B cross A. But you can say, because just opposite. So you can say that A cross B is the negative of B cross A. A cross B is equal to minus B cross A. This is a valid statement. But A cross B not equal to B cross A. But in the case of dot product, A dot B equal to B dot A. Because we are dealing with the scalar quantity only, there is no problem. But in case of A cross B, the resultant vector will be one direction. B cross A, the resultant will be in the opposite direction. So what is A cross B? What is the formula? A cross B equal to mod A into mod B into sine theta into n cap. What is n cap? Again, cap is game. When you are seeing cap, that indicates that is a unit vector. So what will be the direction of n cap? N cap direction will be, if this is A, this is B. This is B. The direction of n cap will be, that is a unit vector. N cap is a unit vector. N cap is a unit vector along the direction. That direction is perpendicular to both A and B. That is n cap. N cap is a unit vector along a direction which is perpendicular to both A and B. So the original vector A cross B is equal to mod A into magnitude of A into magnitude of B into sine theta into corresponding unit vector. So you will be getting a unit vector along this direction. A cross B. So A cross B is equal to mod A into mod B sine theta. Mod A into mod B sine theta. So this much is magnitude and vector is represented by n cap. So by using some example, how to calculate dot product and cross product we will discuss. For example, vector A is equal to 2i plus 3j plus 4k. Vector B is equal to 3i plus 4j plus 8k. So what is A dot B? A dot B. So 2i 3j 4k dot 3i 4j plus 8k. So when you are multiplying, you can multiply everything. So 2 into 3, 2i dot 3i. 2 into 4, 2i dot 4j. 2i dot 8k. But I dot I is 1, I dot j is 0, I dot k is 0. Therefore, in these two cases, answer will be 0. Here, 2i dot 3i, 2 into 3 into 1. What will be answer? 6. So after this multiplication, the duty of 2 is completed. Now we have to select 3 into 2, 3 3 into 4 and 3 into 8. Here 3j j dot I 0. So either you will get 0. Here you will get 3 into 4, 12 into 1. Then here 3 j dot k. Here also you will get 0. Then the next case, using 4 you can multiply 3. Then you can multiply 4. Then you can multiply 8. K dot I, here you will get 0. K dot j, here you will get 0. K dot k equal to 1. So 4 into 8, 32. So answer, what will be answer? 6 plus 12 plus 32. That is 6 plus 12, 18. 18 plus 32, 42 plus 8, 50. So answer will be 50. So this is the example of scalar product, dot product to scalar product. Finally you are getting a scalar value. Now the same thing, 2, 3, 4, 2i plus 3j plus 4k. We can do the vector product. What is A? 2i, 2i plus 3j plus 4k. 2i plus 3j plus 4k, and vector B is equal to 3, 4, 8. 3, 4, 8. So what is A cross B? A cross B. In normal multiplication, 2i, 3j, 4k cross 3i, 4j, 8 cross 8k. Now 2i, 3, 2i. Then one thing I have to say, we can see here. After that, we will discuss that. I cross I can be written as I cap, magnitude of I, magnitude of j, sine theta n cap. What is the angle between I and I? 0 degree. What is sine 0? 0. So 1 into 0. So what will be the answer? It will be 0. So I cross I is 0. Then I cross j. I cross j. Magnitude of I, magnitude of j, sine. What is the angle between I and j? That is 90 degree. That is 90 degree. Into n cap. So I 1 into sine 90 is 1. So n cap. So n cap. What is n cap? N is a unit vector which is perpendicular to both I and k. N is a unit vector which is perpendicular to both the vectors. If you are doing a vector product, then the resultant vector will be perpendicular to both the vectors. Here I is along x direction, j is along y direction. So n cap will be representing the k. That is the x, and if the vector is both perpendicular to x and y axis, that will be along z axis. So what is the unit vector along z axis? That is k cap. So I cross j equal to k. So you will be getting along the positive direction of the z axis. So I cross j cannot be equal to j cross I, but I cross j is equal to minus j cross I. Minus j cross I. I cross j is actually k. So minus of j cross I. If I cross j is along positive direction of the z axis, then j cross I will be along negative direction of the z axis. So j cross I, you can write I cross I is equal to 0. I cross I equal to 0. I cross j equal to k cap, I cap cross j cap, k cap. Then j cross k equal to I. K cross I equal to j. You have to take in order. For example, I, j, k. If you are doing I cross j, that will be k. J cross a, you will be getting I. Then k, after k, you have to put I. Then you have to put j. So then if you are putting k cross I, you will get j. I cross j, again you will get j. But if you are doing in the reverse order, for example, I, j, k, then j cross I will be minus k. K cross j will be minus I. I cross j will be minus j. So you should remember I cross I equal to 0, j cross j equal to 0, k cross k equal to 0. So k cross k, I cross I, j cross j all are 0. But I cross j will be equal to k, j cross a will be equal to I, k cross I will be equal to j. We have to follow in a order. I cross j, k, j cross k, I, k cross I, j आएगा. But in reverse order, k cross j minus I, j cross I minus k, I cross k minus j. So that is the important result. So here you can write like this: 2i, 2i cross 3i. I cross I is 0, so this will be 0. Next one, 2i cross j. I cross j is k, so 8, 2 into 4, 8 k cap. Then 2i cross k. The order is k, after k you should get I. So I cross k is minus, so 2 into 8, 16, 16, so minus 16, minus 16, I cross k. J. K cross I is positive j. So I cross k is minus j. Then 3j and 3i. So 3 into 3, 9. J cross I cross j, k. J cross I minus k. So minus 9k. After that, j cross j, 0. After that, j cross k. So 3 into 8, 24. J cross k, that is normal order, 24i. Then 4 and 3i. 4 into 3, 12. So k cross I, that is normal order. So you will get j. Then you have to multiply 4 k cross j. J cross k, that is normal order. K cross j is reverse order. So 4 into 4, 16. K cross j means it will be minus I. So minus 16i. The next one, 4k cross 8k. 4k cross 8k. Cross means k cross k is 0. So answer will be 0 plus 8k minus 16j minus 9k plus 0 plus 24i plus 12j minus 16i plus 0. So 8k minus 9k, you will get minus k So minus k you are getting minus 16j plus 12j you are getting minus 4j. So this got cut. 24i and minus 16i you will get 8i. Remaining all are 0. So A cross B finally you are getting 8i minus 4j minus k. 8i minus 4j minus k. So this is a lengthy method to calculate the A cross B. This is a lengthy method. So you can follow this matrix determinant technique. A cross B. If A cross B is written, first you have to write the coefficient of A only, then you have to write the coefficient of B only. So I, J, K. What is the coefficient of A? 2, 3, 4. So you can write 2, 3, 4. 2, 3, 4. What is the coefficient of B? 3, 4, 8. So determinant, you calculate the determinant, whether we can check whether both the method is getting the right answer. So I into 3 into 8 minus 4 into 4 plus, so here minus you have to write, minus j into 2 into 8 minus 3 into 4 plus k into 2 into 4 minus 3 into 3. So you are getting I into 24 minus 16 minus j into 16 minus 12 plus k into 8 minus 9. 24 minus 16, 8i, 16 minus 12, 4, so 4j, 8 minus 1, 9, 1, so minus 1 minus k. So we're getting 8i minus 4j minus k. 8i minus 4j minus k. Dekho, you can see both are the same result. Both are getting the same result. A cross B. So instead of doing this lengthy exercise, you can use simply this determinant method. So you can get A cross B is equal to ijk. Then just write the A coefficient, B coefficient, just calculate the determinant. Then you will be able to get the answer very easily. So this is the idea of dot product and scalar product. So we are coming back to our previous case A, and this is vector B. The angle between the two vector is theta. The resultant vector R can be represented as normally A plus B by triangle law of addition A and B. A and B is resultant will be A plus B. So what is A plus B? So magnitude of, for example, if you have a vector xi plus yj plus zk, the magnitude can be represented as root of x square plus y square plus z square. So magnitude square can be represented as x square plus y square plus z square, because you can remove that under root because we are squaring on both sides. So R modulus of magnitude of a vector square is equal to x square plus y square plus z square. Similarly, A plus B is the resultant vector R. R is equal to A plus B. So modulus of R square is equal to, here you can write like this, A plus B. So magnitude of R equal to A plus B. Vector R is equal to A plus B. Therefore, magnitude of R is equal to magnitude of A plus B. So magnitude of R square is equal to magnitude of A plus B square. So this you are getting. Then another example. R is a vector that is already mentioned here. Xi plus Yj plus Zk. So R dot R, what will be R dot R? We can check. Xi Yj plus Zk dot Xi Yj plus Zk. So now we discussed the dot product. So I dot I is 1, I dot j, I dot k, that will be 0. So you need not to do all the steps, just multiply these two. That is enough. So x into x, x square, I dot I 1. Y into y, y square, j dot j 1. Z into z dot zk dot zk, z into z square, k dot k is 1. So you are getting x square plus y square plus z square. So r dot r can be written as x square plus y square plus z square. That is equal to modulus of r the whole square. From this statement, you can understand that a scalar product of a vector can be represented. For a single vector, the scalar product of the same vector can be represented as the magnitude of that vector square. Because we are getting r dot r equal to x square plus y square plus z square. That is the magnitude of r square. So if this condition is satisfied, then here also you can like that. Here our vector is r that is equal to vector a plus b. If the magnitude of r is taken, magnitude of a plus b can be taken. Magnitude of r square is taken, magnitude of a plus b square can be taken. Since a vector magnitude square is equal to the scalar product of the corresponding the same vector, from this example, a vector magnitude square is equal to this product, the scalar product, dot product of the same vectors. Then a plus b whole square can be written as a plus b dot a plus b. A plus b dot a plus b. From this example, model magnitude of a vector square is equal to the scalar product of the same vector. R dot r equal to magnitude of r the whole square. Instead of r, just replace by a plus b. So you will get a plus b the whole square equal to magnitude of a plus b the whole square is equal to vector a plus b dot vector a plus b. So this can be written as a dot a plus a dot b plus b dot a plus b dot b. The same thing can be utilized here. The dot product of the same vector is the square of its magnitude. A dot b dot a both are same. So you can write a dot b plus b dot b. The scalar product of the same vector is equal to the magnitude of vector square. So this can be written like this. So a plus b the whole square is equal to a plus b the whole square is equal to, or magnitude of a plus b the whole square is equal to a plus b. You can write like this. A plus b, magnitude of a plus b the whole square is equal to a plus b dot a plus b equal to a square plus b square plus 2ab. So this can be written as magnitude of a square plus a dot b can be written as magnitude a dot b. What is a scalar product? A dot b means mod a mod b cos theta plus b square. So in magnitude ways, so resultant magnitude, this is actually R only. This is R equal to A plus B the whole square. So this can be written as R only. So R square is this one. A square plus 2AB cos theta plus B square. So the magnitude of A can be written as simply A. Magnitude of B can be written as simply B. So magnitude of R square is equal to A square plus 2AB cos theta plus B square. Therefore, vector R square, that can be written as R only. The magnitude of R can be written as R only. So R square is equal to A square plus B square plus 2AB cos theta. Therefore, R is equal to, you can put like this, A square plus B square plus 2AB cos theta. So that is the resultant of two vectors. So this is a vector A and the vector is B. So you will get a vector like this. This is the resultant vector that is equal to A plus B. The angle between the two vectors, that is actually theta. So the resultant vector is, the magnitude of the resultant is equal to root of A square plus B square plus 2AB cos theta. So R equal to root of A square plus B square plus 2AB cos theta. So understood? So you have two vectors A and B. The angle between the two vectors is theta. The resultant, the magnitude of the resultant vector can be represented like this. R equal to root of A square plus B square plus 2AB cos theta, where A represents the individual magnitude of the vector A, B represents the individual magnitude of the vector B, and theta represents the angle between the two vectors A and B. So that is the magnitude. That this equation represents the magnitude of the resultant vector. We can take some special cases. For example, case 1, theta equal to 0 degree. So what is the resultant? Will be A square plus B square plus 2AB. Cos theta is cos 90. Cos theta is cos 0. So cos 0 is actually 1. So you can write like this. A square plus under root of A square plus B square plus 2AB into 1. This is the expansion of A plus B the whole square. So that can be written as A plus B the whole square. So this is equal to A plus B. So magnitude is equal to, magnitude of the resultant vector is equal to A plus B. If two vectors are parallel, then resultant can just add the two vectors. That is enough. That will be the resultant. Second case, theta equal to 90 degree. So first case, two vectors are on the same direction. So theta is equal to 0 degree. So second case, theta equal to 90 degree. So here the vector will be, one is A, another one is B. Both the angle between the two, that is theta equal to 90 degree. So resultant will be anyway like this. Resultant will be like this, but we don't know the angle. Actually, we don't know the angle because in parallelogram, one thing I will tell you, in parallelogram law of addition, if this is the one vector, another vector is with magnitude B, that is greater than A. So the resultant parallelogram you have to represent like this. So diagonal will be more close towards B, because magnitude of B is more. So another case, if the vector is like this, it's little bit with magnitude, more magnitude, and the other vector is small. So if you are drawing the parallelogram, you will get a diagonal like this, that is more close towards A. So you cannot always say that the resultant vector will be exactly at the middle of the A and B. If the magnitude, because if you are considering two forces, so resultant will be more closer towards the bigger force. So here the magnitude of A is greater than magnitude of B. So resultant is more closer towards A. In this case, the magnitude of B is greater than magnitude of A. The resultant is more close towards the B. So if both are equal, then you can say that will be exactly at the middle. In this special case only, the angle between, if the total angle is theta, this will be theta by 2 and this will be theta by 2. What is the condition? Magnitude of A should be equal to magnitude of B. Then only the resultant will be X, because both are equal strength. So the resultant will not be close towards any of them. It should keep a equal distance from both the vectors. So if magnitude of A is equal to magnitude of B, then the resultant vector will be exactly at the middle of both the vectors. Here you can say that the resultant will bisect the angle between the two vectors. Here in this case only, the resultant will bisect the angle between the two vectors. Here you can see that is the parallelogram law. So in this case, theta equal to 90 degree. Theta equal to 90 degree means theta equal to 90 degree. So what is R? A square plus B square plus 2AB. Here only we need to consider the magnitude only. So R equal to A square plus B square plus 2AB cos 90. Cos 90 is 0. Then you have to put like this: A square plus B square plus 2AB into cos 90 0. So this entire term 0 is, so answer will be A square plus B square. A square plus B square. So if theta equal to 0 degree, both are equal to root of A square plus B square plus 2AB cos 0 1. So you are getting A plus B. If theta equal to 90 degree, R is equal to root of A square plus B square plus 2AB cos 90. Cos 90 is 0. You are getting A square plus B square. If theta equal to 180 degree, that is theta equal to 180 degree, and this is A and this is B, then R will be equal to A square plus B square plus 2AB cos 180 degree. Cos 180 is actually minus 1. So you can write A square plus B square minus 2AB. This is actually the expansion of A minus B the whole square. So R will become the magnitude of R, or the simply R will become A minus B the whole square means A minus B. So if two vectors are acting along the same direction, just add the magnitude of the two vectors. If the two vectors are acting in the opposite direction, just subtract the bigger one and minus 1. So the smaller one can be subtracted from the bigger one, and the resultant will be along the direction of the bigger vector. If the two vectors are 90 degree, then the resultant will be root of A square plus B square. Here also, as a special case, you can take. You can see two vectors A and B. A and B. A and B. If the magnitude A equal to magnitude of B, R is equal to root of A square plus B square plus 2AB cos theta. Theta is the angle between the two. So If the magnitude is same, then magnitude of A equal to magnitude of B. That is equal to A. You can consider either equal to A or either equal to B. So this can be written as A square plus 2AA cos theta. So this can be written as A square 2A square plus 2A square cos theta. So R is equal to root of 2A square into, here you can take a common so that 2A square can be taken out. So 1 plus cos theta. So this can be written as R equal to root 2A into root of 1 plus cos theta. So R equal to root 2A into 1 plus cos theta is 2 cos square theta by 2. So root 2A into root 2 cos theta by 2. So root of 2 is actually 2, root 2 only. Cos square theta by 2 can be taken as so cos theta by 2. So root 2 into root 2, 2A. 2A cos theta by 2. So if two vectors are acting with an angle between is theta, and if the magnitude is equal, then R equal to 2A cos theta by 2. So here also you can consider the special case, theta equal to 0. So R is equal to 2A cos 0 by 2 equal to 2A into 1 equal to 2A. If two vectors are on the same direction, then just add the magnitude A and B, A plus B. If the vectors are 90 degree, then R equal to 2A cos 90 by 2. Matlab 2A cos 45 degree. That means 2A 1 by root 2. So 2 cut, so root 2. So root 2A. Previous case, we told the equation like this, A square plus B square. If A square is equal to B square, so A square plus A square plus A square. So 2A square. So you'll be getting root 2A. The same is here also. Here also same thing is you received. Then theta equal to 180 degree. Theta equal to 180 degree. So here R is equal to 2A cos 180 by 2. So 2A into cos 90. Cos 90 is 0. So answer is 0. So already I told if two vectors are there, AB with angle between A and B is theta, the resultant will be equal to A square plus B square plus 2AB cos theta. So here different cases can be applied. You can consider theta equal to 0 degree, theta equal to 90 degree, theta equal to 180 degree. If theta equal to 0, you have to consider A plus B. If theta equal to 90 degree, you have to consider A square plus B square. If theta is equal to 180 degree, A minus B, how to take. In the special case, if mod A equal to mod B, then in this case, the resultant will be, here also, this is all our resultant. Here R will be equal to A minus B. Here R will be equal to A square plus A square root 2A. Here R will be equal to A minus A. Instead of A plus B, either A plus B, here A minus B, that is A minus A equal to 0. A plus B, A plus A equal to 2A. Here A square plus B square. That means, so this one and this one, here A square plus B square is equal to root of A square plus A square is equal to 2A square. So finally you are getting 2A. So these are the resultant of a two vector. So A plus B, 2A, A square plus B square, root 2A, A minus B, A minus A 0. So these are the different possibility. This way you can calculate the resultant of two vectors A and B. Here, another thing, this is vector A and this is vector B. The angle between the two vectors is theta. The resultant can be represented like this R. If this is alpha, here you can do the concept of projection of two vectors or the vector component of a vector along two perpendicular direction. That if that concept is used, we can calculate the resultant vector direction also. That means you have two vectors A, another vector B, and the resultant is like this. You know the total angle is theta, but you have to calculate the alpha. At what direction the resultant vector is directed? You have two vectors A and B. The angle between the two vectors is theta. Then at what angle the resultant vector R will be going? That is represented as alpha. So the component of the vector means, for example, if it is a vector B and this is the angle theta, then this component can be represented as B cos theta. And the perpendicular component can be represented as B sin theta. By using the Pythagoras or the right triangle concept only we are writing. So, for example, this is B cos theta and this is B sin theta. Then, based on the Pythagoras theorem, B cos theta square plus B sin theta square is equal to, you can feel this is A, this is B, this is A. This can be written as AC square. That is actually B. So B cos theta square means B square cos square theta, B square sin square theta equal to AC square is actually B square. So B square into common cos square theta plus sin square theta equal to B square into 1 equal to B square. That is a valid condition. So the meaning is, if you are given with a vector R and this angle is given is theta, then this component can be represented as R cos theta, and this component can be represented as R sin theta. How much length you have to provide, that you have to do like this. If this is R, this should be R cos theta extension and this should be R cos theta extension. So like this, up to this, if this is theta and this is R, this can be written as R cos theta. You cannot simply extend that R cos theta at any point. That R, the projection of R on the basement, that is R cos theta. And this will be also this much length. This can be represented as R sin theta. This is R sin theta and this is R cos theta. So this is the resolving a vector into two perpendicular direction. Resolving a single vector into two different directions. Along the side of theta, we will put cos theta, R cos theta. Opposite direction, we will put R sin theta. That concept is used here. Resolving a vector into a mutually perpendicular direction. If an angle is given, based on that angle. If this angle is given, along with that angle, that side should be cos theta, R cos theta. The other one should be R sin theta. Here, this is A, this is B. So projection can be like this. This is the 90 degree. So this is theta This can be represented as b sine theta, and this is represented as b cos theta. So you are getting a very big triangle like this. So for example, this is A, this is B, this is C, and this is D. Then by Pythagoras theorem, you can write that is also possible. This is the resultant vector R. This is alpha. This thing's alpha. So tan alpha can be represented as perpendicular upon base. What is perpendicular? Perpendicular is b sine theta. What is base? Base will be this much length. So A plus b cos theta. So tan alpha equal to b sine theta divided by A plus b cos theta. This is a formula for calculating the direction of the resultant vector. Once again, I will tell you. This is a vector A, another vector is B. The resultant can be represented like this, R. So angle between A and B is theta. The resultant vector is a direction of alpha. Then this is B cos theta. This is B sin theta. Then tan alpha can be written as b sin theta divided by A plus b cos theta. So you have two vectors A and B. The angle between these two vectors is theta. Then the question is, what is the resultant and at what direction the resultant will be? So alpha is indicated by that. Alpha is the direction along which the resultant vector is acting. So alpha can be calculated by this equation. So this is all about the basic concept of vectors. So we have discussed what is the difference between scalar quantity, vector quantity, what are the different types of vectors, null vector, free vector, equal vector, parallel vector, anti-parallel vector, negative vector, free vector, localized vector, unit vector, different vectors we have discussed. Then what is the addition law? That is, first one, if the both forces are applying one after the other, then you can go for triangle law of addition. In triangle law of addition, the third side of the triangle will be the sum of the other two vectors. In parallelogram law of addition, if the two vectors are simultaneously acting on a point, then parallelogram law of addition can be used. Here the resultant will be represented by the diagonal of the parallelogram. Then we discussed about dot product and vector product. Normally in linear algebra there is no dot product and cross product, but in vector concept normal multiplication is not there. There are two pros are there. One is dot product and cross product. So what is the difference between cross product and dot product? What is ijk? Then resultant vector and its magnitude, and what is the angle? That is also we have discussed.